This is 2-1, squares and square roots. It is page 5. This is part 2. This is going to be estimate the following square roots. What two integers is the square root between is what they're asking you to do. First of all, they're asking what is an integer. And an integer is a positive or negative whole number. Okay, positive, all positive or negative whole number. Okay, so here we go when we do estimating square roots. I am going to use my chart that I had just done until I start memorizing them. So I have the square root of 15, and if you notice that the square root of 15 falls between square root of 9 and square root of 9 and square root of 16, and that's 3 and that's 4. So the answer is between 3 and 4. Okay, number 2, square root of 40. I'm going to notice that it's square root of 40 would fall in between here. So I'm going to write the square root of 36 on one side, the square root of 49 on the other. That's 6. Square root of 36 is 6. Square root of 49 is 7. So the estimate of square root of 40 is between 6 and 7. Square root of 75. Square root of 75. I'm going to look on my chart. It is between the square root of 64 and the square root of 81. Square root of 64, which is 8. Square root of 81, which is 9. So the answer is between 8 and 9. Square root of 27 is between square root of 25 and square root of 36. Square root of 25 is 5. Square root of 36 is 6. So this is between 5 and 6. Square root of 11 is between square root of 9 and square root of 16. So that would be square root of 9. That would be square root of 16. That's 3. That's 4. So that's between 3 and 4. Square root of 99 is between the square root of 81 and the square root of 100. Square root of 81 is 9. Square root of 100 is 10. So the answer is between 9 and 10. Square root of 84 is between the square root of 81 and square root of 100. So between 81, which is 9, square root of 100, which is 10, between 9 and 10. So this part right here, when I write square root of 81 and 9, square root of 110, that's my shown work, and that is required of you. Square root of 23 is between square root of 16 and square root of 25. Square root of 16 is 4. Square root of 25 is 5. This is between 4 and 5. Square root of 50 is between the square root of 49 and the square root of 64. Square root of 49. Square root of 64. Square root of 49 is 7. Square root of 64 is 8. So between 7 and 8. So what I am doing is I'm finding the perfect squares on either side of the number, then finding out the square root of the perfect square, and then telling you what two integers they are. Okay, next step. Solve each equation, drive a model for each problem. Okay, x squared equals 121. That means I have an x by an x, and 121 is inside. If I have a square with the area of 121. I'm taking the square root of 121, which is 11. Two sides labeled B and B with an area of 196. The square root of 196 is 14. So B is 14. Over here, X is 11. Put a box around your number so I know what your answer is. A square napkin, draw my little square, has an area of 36, which means it goes on the inside. What is the side length? Since it's a square, all sides are equal. X squared equals 36. Taking the inverse of a squared is taking a square root. Square root of 36 equals 6. So X equals 6. So each side of the napkin is 6. Okay, next part. Write in exponential form. These are the bases. They are alike. The base is 4. The exponent is 3. 1, 2, 3. Y is the base. Count them up. 1, 2, 3, 4, 5. There you go. The negative 1 is understood, so you put a negative for the negative 1. You put a 9, you put the M, and you notice that there are 2, so you square the M. These are all negative 3's. You must leave them in parentheses. Count them up. 1, 2, 3, 4. Negative 3 to the 4th. If you did not put your parentheses, it would cause it to be a different answer. This is 1, 2, 3, 4. There's 3 of them. There's 4 3's. Put the negative 1 outside. 7 to the 0 is 1. There is a rule. All numbers raised to the 0 power equals 1. 285 raised to the 0 power, 1. Anytime you have a raised to the 0 power, it's 1. Next one says write out the expression and then evaluate the powers. 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 9 is 81. That is 81. Here it's negative 5 times negative 5, and negative times a negative is a positive, which is 25, positive 25. This is negative 5 times negative 5 times negative 5. A negative, when there are 3 negatives, it will stay a negative. 5 times 5 is 25, and 25 times 5 is 125. So the answer is negative 125. This is a negative with a 5 and a 5. That exponent is only hooked to the 5. Negative times a positive is a negative 25. The next step says evaluate the following expression if A equals 2, B equals 5, and C equals negative 2. Evaluate, plug, and chug. So you do 3, A is a 2, plus 5 cubed. This is 3 times 2 plus 5 times 5 times 5. That's 6. 5 times 5 times 5 is 125. To give you a total of 131. The next one is b squared over 15a squared. Sorry, b over 15a, all of it squared. B is 5. 15 times 2, and all of that squared. You can mess with big numbers. I prefer factoring out. I'm going to take and factor a 5 out of here and here. That becomes a 1. That becomes a 3. That's 1 times 3 times 2 squared, which is 1/6 squared, which is 1 over 36. The last one is c squared, which is negative 2. Notice I put it in parentheses, minus 5 plus 2. Negative 2 times negative 2 is positive 4, minus 5 plus 2. 4 minus 5 is negative 1 plus 2. That is an answer of 1. Go to part 3 in your videos to finish out the notes, and then you will be ready for your assignments.